Next we will write the testbench part. So here I am copying my testbench into the testbench.sv. So initially you need to import your UVM package. So these are the files that we are going to write in this example finally. So often when we write new files, we will add them and include them. So let it be there for the time being. Let all of them be here. But when we get compile errors, we'll comment out them. And in the module testbench, I have instantiated the interfaces with the appropriate names, and again instantiated the MUDUT and connected them by using the same name with these interfaces. And this is to dump the signals and see the waveform, clock generation. Next is reset generation, and this is main initial block where we will do all the UVM steps. So what you need to do here is, first you need to write the first you need to instantiate the UVM interface configurations, and you need to initialize them. Then you need to set up the interface configuration. Then you need to run the test. So we'll come to this part at the end of this course. So let us comment out, let this part be here as it is. But if you compile at this point, you'll get a lot of compilation errors. So first we will write this tbdefinitions.svh file. So first one is an enumeration for master and slave. So agent type enumeration is defined. Next, I am adding another UVM sequence definition, like UVM sequence parameterized with sequence item as UVM virtual sequence. So this is optional. If you are using virtual sequences in your testbench, you can define this type def, and you can extend all your virtual sequences from here. So it's up to you. And next, you need to define this interface configuration. So first one is an interface agent configuration. So this is a general interface agent configuration. So these are the configurations that you need to set up on an interface in general. So first, you need to see whether it is active or passive. So there UVM active passive enum is already available with the UVM. So you can see whether it is active or passive. And next one, you can say whether it is a master or slave. So if it is an active agent, it could be a master or slave. So we are using this type def here, master or slave. And also you can add other controlling parameters like checks enabled, coverage enabled, always ready. So this can be used to drive ready or tie ready to high in a slave driver accordingly. So these are some general configuration information for almost all agents or all interfaces. So I'm defining it as an interface agent configuration. And next one is an AXI agent configuration, which is extended from this class. So all these parameters will be available. And also, to make things easy, I have added all the virtual interfaces into this interface, all the virtual interface types into this in AXI config. So all the virtual interfaces will be available in this AXI agent configurations, along with the basic interface config parameters. Remember to add this new function here in all of them. And finally, I am defining another configuration, which is the ENV configuration. So in the ENV, we are adding the number of AXI ENVs as another configuration. The advantage is that you can scale this environment to multiple environments or multiple DUTs or multiple test benches, or even while writing this specific code, you can make initially to the number of ENVs to 1 and correct all the errors. Then you can make it to 2 and so on. So in the TB ENV config, I have a configuration parameter which is number of AXI config, which is defaulted to -1, so that you will make sure that you are always giving a proper value to this. And accordingly, there will be 2 AXI agent configurations which need to be passed down to the individual AXI agent. So it's a dynamic array. So again, in this ENV config, there is another function to set the number of ENVs. So once you pass the number of ENV, you need to set this value, and again you need to initialize this dynamic array config, AXI config dynamic array accordingly. So if you pass the number 2 here, there will be 2 AXI configs within this dbenv config. And then the last one is a cyclic master ID generator. So in the environment, in our DUT, we have 2 AXI interfaces, and to make things easier, we are adding a constraint to this AXI IDs. Say that all the IDs in the interface, in the AXI interface 1, only IDs from 0 to 7 is allowed, and in the interface 2, only IDs from 8 to 15 is allowed. To generate these IDs randomly, repeatedly, but in a cyclic manner, I am using this class. So this is my own class. I'm defining 2 variables as ranc here, which will go up to count up to say 16. And again, I am limiting their values. For the first one, it is inside 0 to 7, and second one is inside 8 to 15. So by using this class, I will be able to easily get a cyclically repeated pattern of numbers, which is from 0 to 7 and from 8 to 15. Now let's go back to the test bench and see what all we have done with this configuration objects in the test bench. So this was a tbenv config, and this was your AXI config, and this which was extending from the interface agent config. Now in the initial begin part of your test bench where the UVM is set up, first you will declare all of them. You will define 2 AXI configs and 1 env config. This env is your top, very top level env, and you will new them, and you will say it's an active, AXI1 is active, and it's a master slave mode is master, coverage enable is 1, checker enable is 1, always ready is 1. So you can drive 1 initially, then you can delete it later. Once your TB is stabilized, you can come out and test it. And also you need to pass this interface accordingly. So remember that we have these interfaces are already declared here, so you need to pass them into this configuration object so that they can be easily accessed from the UVM components. So the same interface is passed into the DUT as well. So while driving from a UVM driver, it will be driven into DUT. And in the same way, the AXI config 2 is set up. And finally, the env config is created, and we are setting in the number of envs as 2 here. So initially, when you start coding, you can set it up to 1 here, and you can comment out the second one. You don't need to do it here, otherwise you'll get a compile error. But this is the final code. So when you set up number of env2, and the first AXI configuration is this one, and the second AXI configuration is this one. So we have nicely organized the env configurations, and the only thing that now remaining is to add it to the config DB so that any other components can access them. So I'm adding it to the config DB like config DB parameterize with dbenv config type, call and go and set. The first one is the UVM top star. This is the config interconnect env name. This is the name of this config object, and this is actual value passed to this. And finally, you need to call the run test, which is the basic UVM mechanism of creating a top level test and running it. So at this point, if you comment out the run test and compile things, it should be pretty stable. Yeah, there are multiple compile issues. First one is coming from this DB definitions, the UVM sequence part. So you can see that I haven't enabled UVM here. So you need to enable UVM in this library. So I'm adding UVM 1.2 here. And now if I run, again I should get compile error because I haven't defined any of these files. But let's see, they'll be flagging compile errors. So for the time being, I'll be commenting out all of them, and I will run it again. And let's see what happened. So you can follow the same kind of steps to reproduce these setups in your own playground. So this is how you go for a step-by-step approach while you develop a complex environment. So don't worry, nothing is stopping here, because there is nothing is running and no $finish will be called from here. So let's stop this thing. As long as there is no compile error at this stage, they are fine. There is no compile error. In the module, there is nothing is happening. No stimulus is injected, and there is no $finish called because we are not calling the run test. So its code is compiled clean at this point. Let's save it and move on.